Okay, working with this particular functions right here. We're dealing with asymptotes, lines that cannot touch. Can't touch this. Got to have a little MC hammer. Can't touch this. Can't touch this. But what I know is this. Remember, I'm going to put this little coefficient 1 here. Horizontal asymptotes are based strictly on the leading coefficients of the highest degree. Both these degrees are 1. So it is that y equals 2 over 1 or y equals 2, which makes this a horizontal at y equals 2. And the vertical occurs when the denominator cannot be 0. So x minus 3, when it equals 0, is where the asymptote is. Add 3 to each side, so it's x equals 3, which makes the vertical. So, I know there's a horizontal at y equals 2, and a vertical at x equals 3. Now here's the right numbers, but notice it says horizontal at x equals 3. That's not right. A vertical asymptote at x equals negative 3. No, inside liars here. It's not B. A vertical asymptote at x equals 3. That's true. And a horizontal asymptote at y equals 2. Yes. The answer is C. All right, now following this part right here, here's what I notice about this particular problem here. We'll look at the choices in a second. Let's go ahead and look at our graph. Notice, 1, 2, 3. It looks like to me there's a vertical asymptote at x equals negative 3, meaning there'll be a vertical asymptote at x plus 3 somewhere on the bottom, because it's an inside liar. The other thing I know is this. There'll be a horizontal asymptote at 1, 2, 3. It's like there's a horizontal asymptote here at y equals 4. Well, if this has a coefficient of 1, I need a 4x up here. Doesn't matter what that is, although kind of looking at it, 1, 2, 3, 4, this number here's got to be something between 4 and 5. If you think about what 12 divided by 3 is 4, and 15 divided by 3 is 5, so somewhere between 12 and 15 will be our number right here, just kind of as a, has to be like 13 or 14, we don't really know. So let's go look at what our choices are. As I scroll up, I know there has to be an x plus 3 on the bottom, and there has to be a 4x with some number up there like that. And so let's look at it. What's the things? Oh, a 4x minus 13. No, that's not right. Oh, wait a minute. I see a 4x plus 13 and an x plus 3 on choice J. Here we go. There is the answer. Yay! And doesn't say it had the x plus 3 with the 4x in there. Positive some number like that. Also, you can maybe graph those to see which one it looks like. We have another problem with asymptotes. So let's look at it real quick. And it is, I believe, we have 2 problems with asymptotes. I believe we have problems 47 and 42. Oh, actually 44. So let's look at 44 first. Which of the following equations is true about the equation hx? Well, I'm going to kind of look at this the same way. Here's what I know about hx. Looks like to me I got an asymptote here at, I'm looking at the particular problem, I want to make sure I look at 44, how those dots are coming around. Yes, this is at negative 1, meaning I'm going to have an x plus 1 in the denominator. And I also have one at 1, 2, 3, which is a plus 3, which means I'll have x minus 3. So I need to have x plus 1, x minus 3 in the denominator. And because there's a horizontal asymptote here at 0, that means it will probably not have any x, but it should be a number here. Would probably be the case. X plus 1 times x minus 3. So let's look at our choices, which you happen to have on your paper. And as I'm looking down at the choices, it looks like to me it will be choice H. The denominator, notice I know it's not the numerator, those two right there. The denominator, x plus 1, x minus 3, notice those, because they had to be inside liars. All right? So the answer to that one was choice H. All right? Let's go back and let's look at problem 47. Oh, it's kind of like 47, a little easier to see here. for us. Wrong way. So we have to do this yourself. We have x squared over x plus 5. Which of the following statements is true of the graph? Well, here's what I would do. That's 1x squared, and I have 0x squareds down here. Meaning 1 over 0 is my horizontal. Can you divide by 0? No. So there's no horizontal. However, because there's a 0 down here, that means I'm going to have a slant asymptote in my problem. And there is a vertical asymptote at x equals -5, because that's an inside lie, or x plus 5 would be x equals -5. So there is no vertical. That's not true. There is a vertical. There is a vertical and a slant. Yes, I believe that is true, and that is the answer. There's a horizontal? No. There's a vertical and a horizontal? No. The only correct answer is choice B. All right? And I believe we just talked about a slant asymptote. So let's actually find out how we find a slant asymptote, which is problem 42. So here we go. How are we going to find the slant asymptote for this particular problem right here? And it looks like my J particular answer to this did not show up. However, J is not the right answer for this problem anyway, so that's no big deal. But let's erase this here so we can see how to find the slant asymptote. All right, here's how you find the slant asymptote. 3x squared minus x minus 2, simply divided by x minus 1. Now you can divide it that way, or I personally prefer to use synthetic division. If that's a -1, I'm going to put a +1 in my thing here. I have a 3, a -1, and a -2. Right here. Bring down your 3. 1 times 3 is 3. -1 plus 3 is 2. 1 times 2 is 2, which gives that 0. So basically what we're going to have is this. Notice we started with x squared. So 3x plus 2 is our slant asymptote. Put a y equals in front of it. Makes it letter F. Y equals 3x plus 2. So was the correct answer. Now choice J, which is not showing up, which is not important. That was the choice for it, but that was not the answer. The correct answer is, but you just got to divide this into this. And to me, synthetic division is the much easier way to go to solve the problem.